Good morning. Today I am going to explain about ammonia. What is its property, how it is prepared, what is its physical property, what is its chemical property, what are the uses of ammonia, and many more I am going to explain in this class. So first of all, we'll see what are the molecular formula of ammonia. Molecular formula of ammonia is NH3. Here nitrogen is a central atom. It has 5 electrons in its valence shell. From that 3 electrons are shared by hydrogen atom to complete the octet structure for nitrogen and duplet structure for nitrogen. So we can say nitrogen is having 2 lone pair of electron. This is called lone pair of electron. So question can come, what is a lone pair of electron? Lone pair of electron is non-bonding electron which doesn't take part in molecular bonding or doesn't take part in bonding. What is lone pair? Once again, what is lone pair of electron? Lone pair of electron is a non-bonding electron which doesn't take part in chemical bond. Next we'll see about ammonia. What is its smell? It is pungent, choking smell. It is we can say suffocating smell. It is not poisonous. We can say it is non-poisonous gas. But when you inhale for the long time, it may cause death for the long time inhalation. Now the next point you will see where it occur. Occurrence of ammonia. Ammonia occur in free state also. It occur in combined state also. Free state means it is occurred in the atmospheric air. Combined state means it occurred in any compound like ammonium chloride, ammonium sulfate, ammonium nitrate, ammonium nitrite. In these compounds ammonia is present but not in free state. It is in the combined state. Ammonia is also present in urea. You can say urine. Ammonia is also present in urine, but by bacterial decomposition urea gives ammonia by the bacterial decomposition. These are the introduction of the ammonia chapter. Now in the next section I'm going to explain about types of ammonia. Ammonia exists in 4 types. The first is gaseous ammonia, second is liquid ammonia, third is liquor ammonia, and fourth is liquid bench reagent ammonia. So all 4 having different roles and different uses. Try to understand between a liquid ammonia and liquor ammonia. Liquid ammonia means when gas is changing from changes from gaseous state to the liquid state by applying high pressure. We are not using water solvent, but still it changes into liquid by applying high pressure. That form of gas is called liquid ammonia. Liquor ammonia means very simple, we add water to change into aqueous form. This is called liquor ammonia. Now in the next section I am going to explain how to prepare ammonia in general. For the preparation of ammonia we take salts of ammonia. Salt of ammonia. Salt of ammonia means you can take NH4Cl, you can take ammonium sulfate, you can take ammonium nitrite, you can also take ammonium nitrite, but these 2 are not used for the preparation of ammonia. Try to understand the reason why ammonium, this is called ammonium nitrate, this is called ammonium nitrite. Why these two are not used? The reason is this is explosive in nature. This is explosive in nature, and on heating, when you heat these salts of ammonia, ammonium nitrate, you will give laughing gas plus water vapor, and ammonium nitrite will give N2 plus water. So because of that nature, these two salt of ammonia are not used for the preparation of ammonia. So for the preparation of ammonia, we generally take ammonium chloride and ammonium sulfate. When these salts react with base alkali, you can take calcium hydroxide, you can take potassium hydroxide, or you can take sodium hydroxide. When they react, it gives ammonia gas, NH3 plus water plus salt. What will give? Salt plus water plus ammonia gas. This is the concept. So what is left now? If we break into ions, it will break into NH4 plus and Cl minus. It will break into Ca2 plus and OH minus. So from the product you can see that we have now written calcium plus ion and Cl minus ion. So these two react and give CaCl2. Similarly, it can give, if taken K, it can give K2SO4 plus water plus ammonia gas. If you have taken sodium hydroxide, it will give Na2SO4 plus water plus ammonia gas. This is the general method of preparation of ammonia. Now I am going to explain the next method of preparation of ammonia, that is called laboratory preparation of ammonia. How ammonia is prepared in lab. So for preparation in lab, there is a setup of apparatus. You can see in your book, this setup is set up in lab. Here this is the flask, which is positioned in tilted, and it is connected through the connecting tube to the another jar, and that jar is containing quicklime, is used as a drying agent, and next it is passed to the connecting tube and it goes to the another jar, and there ammonia gas is collected. So you can see that in the first jar it is taken calcium chloride and slacked lime CaOH whole twice. So we can say that for lab preparation, the reactants are ammonium chloride and calcium hydroxide. These are the reactants which are used in laboratory for the preparation of ammonia, and the ratio is always 2:3 by weight. 2:3 by weight. So when reactions takes place between these two, it can break into ion, it can break into NH4 plus and Cl minus, and it can break into Ca2 plus and OH minus. Positive of first go with negative of second and gives water plus ammonia, and negative of first reactant will go with positive of the second reactant, and cross multiply the radical, it will come here and one will go that side, it gives CaCl2, and then we have to balance the equation. So by this method ammonia gas is prepared. There are many things that you have to remember. The first is when this gas is formed, it is dried. It is dried by using quicklime, CaO, calcium oxide. So question can come, why calcium oxide is used, why not other drying agents? There are many drying agents like P2O5, concentrated H2SO4 and many more. Why these are not used to dry ammonia gas? Reason is this ammonia gas is basic in nature in aqueous, so it will react with P2O5 or concentrated H2SO4 and forms other compound. So this is why P2O5 and or concentrated H2SO4 are not used to dry or purify ammonia gas. And in next section you have to remember how to collect ammonia gas during the laboratory preparation. So ammonia gas is collected by upward displacement of upward displacement of air. You can see in the diagram when ammonia is passed through the connecting tube, ammonia is going up. Ammonia is going up means it is lighter, that's why it is going up. And when it goes to the container, air is coming down. Air is coming down means which side is movement? Movement is downward. Whose movement? Air movement. So that is called downward movement of air. So how ammonia is collected? It is collected by downward movement of air. In the next section also you have to see that why ammonia is not collected over water. This question can come. So answer is ammonia is highly soluble in water. That's why it is not collected over water. So these are the points related to the laboratory preparation of ammonia. One more thing, you have seen just in the diagram, the apparatus is placed in tilted position. Why? Why it is not placed in vertical position? Answer is if it is placed in the vertical process, and as we know, along with ammonia gas, water is also forming. So if water is heated, it changes into gaseous form. When it goes to upper level, then the temperature will be less. If temperature will be less, then it again changes to gas to liquid and trickle back to the container. And as we know, जब कोई ठंडा पानी अगर शीशा पे पड़ता है तो टूट जाता है, तो पानी जैसे ही नीचे आएगा वापस आएगा कंटेनर में, तो ग्लास क्या हो सकता है? फूट सकता है, टूट सकता है. दैट्स वाई apparatus को इस पोजीशन में रखा जाता है कि जो वाटर वेपर बना वो भी क्या हो जाए? बाहर निकल जाए, वो trickle back नहीं होता. That's why apparatus is position tilted. So this question also can come, so must remember. One more thing, here you can see that the ratio of ammonium chloride and calcium hydroxide is 2:3 by weight. Why? So reason is here ammonium chloride is a sublime particle. It is sublime. So if its weight is more, then it can vaporize. Sublime means it will change into vapor. So that therefore the calcium hydroxide solution is taken more by weight. So that ammonium chloride dissolve completely in calcium hydroxide solution. That's why the ratio is taken 2:3 by weight. So these are the terms related to the laboratory preparation of ammonia. One more method is given for the laboratory preparation of ammonia is, in spite of taking ammonium chloride, you can take metal nitrides. You can take metal nitrides, and when metal nitrides react with warm water, it always gives metal hydroxide. It gives metal hydroxide plus ammonia gas. In your book given two metal, one is magnesium, another is aluminum. So what will be the formula of magnesium nitride? Nitride, we know that it is trivalent and magnesium is divalent. So formula will be Mg3N2. And aluminum is trivalent, nitride is trivalent, so formula will be Aln. So when it reacts with water, warm water, then it break into ion, Al3 plus and Aln, N3 minus. It will be in H plus and OH minus. So positive of first will go with negative of second. So what formula will give here? LOH whole thrice, and negative of first will go with positive of second, cross multiply, then it gives NH3. Similarly, here we will give MgOH whole twice plus NH3 gas. This is the another method by which ammonia is prepared. Now we'll see how this, we are talking here ammonia gas, preparation of ammonia gas. Now the next section you can see preparation of aqueous ammonia. How aqueous ammonia is prepared. Formula is same, NH3 aqueous. It's very simple. When ammonia gas is passed over water, then aqueous ammonia is formed. Here may back section occur, and back section I will explain it later on, or you can see in your book what is back section. Back section generally when the supply of gas is less and the pressure where the gas has passed over that means in water, जब supply गैस का सप्लाई कम हो जाए और जिस में गैस जाके डिजॉल्व किया वहाँ का प्रेशर अगर ज़्यादा हो जाता है तो क्या हो जाएगा, वहाँ का जो वाटर सॉल्यूशन है वो क्या कर वापस आने लगेगा इन द फ्लो ऑफ अपोजिट डायरेक्शन ऑफ द फ्लो ऑफ द गैस. दिस इज कॉल्ड बैक सेक्शन. तो बैक सेक्शन को कैसे मिनिमाइज करेंगे, टू इंक्रीज द सरफेस एरिया ऑफ द कंटेनर, that will minimize the back section. In the next section, I will explain another method of preparation of ammonia that is called Haber's process, and that I will explain, or that I will deal in the next class. So today I am going to end here with the preparation of ammonia gas by laboratory preparation. Thank you.